Welcome to my YouTube channel. In this video lecture, I am going to answer the remaining 11 questions from this DME chapter, Oxford Radio Lab. So let's begin with question number 11. The transmission frequency of a DME is 63 MHz removed from aircraft interrogator frequency. To prevent what? Now as you all know, let's say this is your DME ground station, right? And here is your aircraft in the atmosphere. So this aircraft is your nothing but this aircraft is your interrogator. In case of DME, aircraft is your interrogator and the DME ground station becomes your transponder. Okay. Aircraft will transmit interrogation pulses in the direction of in all directions basically. Now when this reach the DME ground station, DME ground station at a frequency of let's say 962 megahertz. Okay, DME ground station will wait for 50 microseconds and retransmit the pulses in all directions, omnidirections. So the reply pulses will be going back to aircraft at a different frequency of let's say 63 megahertz difference. So 962 plus 63 is 1025. Okay, so always the reply frequency will be 63 megahertz plus 63 megahertz or minus 63 megahertz. Now we all know DME operates in the frequency band of 962 से लेके 1213 megahertz. So there is only option. So when interrogation frequency is 962 itself, the starting one, you can only add, right? So I have added 1000. I have added 63 in order to get 1025. Now why is this done? To prevent what? Okay, so it is done to prevent interference from other radars, airborne receiver locking onto primary returns from its own transmissions, static interference, receiver accepting replies intended for other interrogators. So the correct answer is option Bravo. Okay, so when DME based on secondary radar principle, so it operates on two different frequencies, right? So if there is any reflection coming from the ground surface, any building object around the DME ground station, this reflections will be rejected by the interrogator or the DME receiver on board your aircraft. It will accept only those pulses which are only those reply pulses which come at a certain frequency which is 1025. Any reflection will be at the same frequency as 962 megahertz. So the DME receiver will come to know that and it will reject those reflections or returns coming from the ground. So the correct answer is airborne receiver locking onto primary returns. Primary returns are nothing but returns or reflections. Now primary radar is based on this principle, the reflection or echo principle. Whatever radio energy is sent to the aircraft target, that radio energy goes to the aircraft target, strikes it and gets reflected back. So the transmission frequency and the reception frequency are the same. So that's why it is called primary return. Basically, it's nothing but a reflection. So from its own transmissions. Now option A, interference from other radars. Now in order to prevent interference from other radars, your DME will transmit twin pulses. DME will transmit twin pulses. Twin pulses are nothing but pulse pairs. And this enables the DME receiver to differentiate between its own twin pulses and any other pulses originating from any other secondary radar like secondary surveillance radar. So option A will be wrong answer to this particular question, but this will be the right answer in if the question asks how does the DME receiver differentiates between its own pulses and pulses belonging to other secondary radar, then option A will be the answer. Static interference, receiver accepting replies intended for other interrogators. Now, this is done, this is achieved. The DME receiver in your aircraft will only accept those pulse pairs, reply pulses, which are made for itself, exclusively for itself. It will reject those pulse pairs which are meant for other aircraft. So every aircraft has the ability to do this, accept only its own unique pulse pairs and reject those pulse pairs which are not intended for itself but are meant for other aircraft. That is done by jittering the PRF. Jittering means jittering the PRF, pulse repetition frequency. I have explained that many times in my previous videos of Keith Williams and Oxford. Question 12. The accuracy associated with DME is plus minus 0.25 nautical mile plus 1.25 percentage of range. Let's say DME indicates that you are at a slant range of 100 nautical miles. So this slant range should not exceed an error limit of plus minus 0.25 nautical mile. Add that to 1.25 percentage of range. So plus minus 0.25 nautical miles plus 1.25 percentage into 100. Range is 100. So plus minus 0.25 nautical mile plus 1.25. So zero point 0.5 nautical mile is the limit. Okay. So it cannot exceed an error of zero point 0.5 miles. Next, question 13. For a VOR and a DME beacon to be said to be associated, the aerial separation must not exceed how much distance in a terminal area. So in a terminal area, it should not exceed a distance of 30 meter or 100 feet and dash outside a terminal area 600 meter or 2000 feet. So I have covered this concept many times. Okay, so there are three conditions or criteria that regards VOR and DME facilities to be associated. So first is both transmitters to be co-located, exact same location. Second is the maximum difference between them. The maximum distance between them should not exceed 30 meter or 100 feet in terminal area, not exceed 600 meter or 2000 feet outside terminal area. Okay, next. DME is a dash radar. So always DME is a secondary radar. Remember, operating in the dash band. It operates in the ultra high frequency band and uses dash in order to obtain range information. It uses twin pulses to obtain range information. Next, the receiver of airborne DME equipment is able to lock on to its own reply pulses because okay, it will lock on to its own reply pulses, meaning it will accept only those reply pulses which are exclusive to itself, which are unique to itself, and reject all those reply pulses which are intended for other aircraft. Now, how is that done? I have told that many times by jittering the pulse recurrence frequency. So each aircraft has its own transmitter frequency and receiver only accepts reply pulses having this frequency. No, that is wrong. That is done in order to prevent or avoid ground reflections from interfering with DME operation, not for this particular purpose. The reply pulses from the ground transmitter have the same frequency as the incoming interrogation pulses. No, always the ground transmitter frequency will be different from aircraft interrogator frequency. Aircraft receiver only accepts reply pulses which have the same time interval between successive pulses as the pulses being transmitted by its own transmitter. Yes, and this is wrong. So aircraft receiver only accept those reply pulses which have the same time interval between its consecutive pulses. In simple words, let's say there is aircraft 1 in the atmosphere. This will transmit pulses and the time interval between these pulses will be, let's say, is let's say 5 seconds. So this will be the same. This time interval will exclusively belong to this aircraft number 1. Now there is another aircraft number 2. There is another aircraft number 2 in the atmosphere. It will also transmit pulse pairs, twin pulses, and the time interval between this pulse pairs will be different from the time interval of this aircraft. So let's say these are the pulse pairs. So the time interval in this case for this particular aircraft is, let's say, 8 seconds. So this is how all pulse pairs are unique to aircraft. So the correct option is option C. Aircraft receiver accepts reply pulses which have the same time interval between consecutive pulses as the pulses being transmitted by its own transmitter. So it will accept only those reply pulses which are also set at this time interval. Okay, it will reject those pulse pairs which are at different time interval like this. Now, very important practical question of VOR. By the way, I have also solved and answered all VOR based questions from Keith Williams, Oxford book, RK Bali, and uploaded it into my channel. So do watch that. Now here we have been given OBS selector and it is set to 045. We get from indication. The DME is telling us a distance of 40 nautical miles. So let's say this is your VOR DME station. Okay, VOR DME station. This is the north datum. Radial 045 is what you have selected. So let's say this is your radial 045. Then you select radial 045 and you get from indication. That means you are following this radial 045 outbound from the station, away from the station. Okay, so your aircraft is, let's say, here somewhere. This is what should ideally happen in correct situation, and your distance is 40 nautical miles. Okay, 40 nautical miles. So you are here. So when this happens, your OBS selector should show something like this. From indication 045 OBS, and the CDI needle should be established right in the center. Should be established right in the center of the instrument. Okay, but over here the CDI needle has moved a little bit to the right hand side. A little bit to the right hand side between two dots, the first and the second dot. So the general rule is that we follow in VOR navigation, follow the CDI needle. Okay, follow the CDI needle. That means if the CDI needle goes to the right hand side, you turn right. If the CDI needle goes to the left hand side, you turn left, so as to intercept or come back to your original radial that you have selected in the OBS. Okay, now in this case, okay, in this question, CDI is 1.5 dots to the right. 1.5 dots means how many angle? 1 dot is 2 degree. Okay, 1 dot is 2 degree. So 1.5 dots will be how much? Cross multiplied 2 multiplied by 1.5. 2 multiplied by 1.5, which is 3 degree. That means angular deviation is 3 degrees. Okay, CDI is the solution. Okay, whatever Syria tells you to do, you do that. So it is basically giving you a solution to some problem. Now what is the problem? The problem is you have selected the OBS 045, radial 045, you are you are located, or your position is located on radial 042. This is the problem. Syria needle is telling you to go right hand side, it will tell you to go right hand side only when your aircraft, instead of being correctly established on this radial, is deviated to the is deviated somewhere to the left hand side, somewhere here. We are expected to be on this radial, but we are to the left of that radial, going outbound. This becomes your left hand side, this becomes your right hand side. Okay, that perspective. So currently you are situated on a wrong radial, and what is that wrong radial? It is radial 042. How radial 042? Because this is radial 045, the correct one. Angular deviation is 3 degree. So 3 degree to the left hand side. Now whenever you go left, angles decrease, directions decrease in value. So 45 minus 42, 45 minus 3 degree is 042. So that means at the time of the observation, aircraft is currently situated on radial 042, option A. Next question, still air conditions, that means no headwind, no tailwind, no crosswind. On regaining the center line, that means from this current position, you come back to your original radial where you are expected to be. You come back here, okay, on this radial. So when you come back to this radial, what should be the change in the heading? What alteration of heading you must do in order to continue on that radial outbound? So we will do it like this. Radial 045, radial 042. Now we have to stop this deviation. So we will use double the track error method. Double, because we want to regain our track. Double the track error method that we have learned in 1 in 60 rule. So currently your aircraft is deviated somewhere here. Radial 045, radial 042, the track error is 3 degrees. 40 nautical miles away. Okay. So step 1, use the formula. Track error angle is distance of track. Distance gone 60. Track error is 3 degree. Distance of track unknown. So let it be like that. Distance gone 40 into 60. Distance of track will be 3 into 40 by 60. So that is 2 nautical miles. So this is 2 nautical miles. Now from this position, we are going to come back. Okay. Now corresponding angles are equal. So if this is 3 degree, this will also be equal to 3 degree. And we have to double this track error. That means Again, from here, first we will have to make a right hand turn, right hand 3-degree turn in order to stop the deviation. In order to stop the deviation going outbound like that. When we make a right hand turn, right hand 3-degree turn, we will be flying parallel. So again, we will have to make another right hand 3-degree turn, another right hand 3-degree turn to fly this particular heading like this. So your aircraft will be flying this heading like this. Now when we come back to our original radial, which is radial 045, we will have to again, this is in total 6-degree right turn, we will have to again make a left hand turn so as to fly on this radial outbound like this. Otherwise, what will happen if we don't make that alteration in heading? We will continue flying outbound like this, away from that radial again. So as soon as we come close to that radial 045 and the CDI needle starts moving in the center, okay, we will start making a left turn. We will start making a left turn, properly timed left turn, and then intercept that radius 045 and fly outbound. So what will be the amount of left turn you will do here? So over here, left turn of 3 degrees. Left turn of 3 degrees. Okay. Because again, this is 3 degree. So this will also be equal to 3 degree. Again, corresponding angles are equal. So when you reach this point, again, you will start making a 3-degree left turn. So left turn of 3 degree to fly outbound on radial 045. So correct answer is, assuming still air conditions, it will be necessary to follow alteration of heading of heading. So they have asked us heading, not the angle. So it is 3-degree turn, left hand turn. So currently we are at, so over here the heading is 045. Heading 045 plus 6 degree is heading 051. At this point, when we reach here, we will have to subtract heading 051 minus 3 degree, which is 048. 048. Okay. So the correct answer here will be left onto 045, right onto 048, left onto 225, right onto 225. So it's definitely a left turn. Okay. And you will make a uh, left turn on a heading of 045. Okay. Not 048. So let's subtract this. So let's make this 6 degrees. 051, 6, that is 045 degree is the correct answer, because very important, one thing I missed, it's still air conditioned. So there are no crosswinds, right? So there are no crosswinds. So you did not make any crab angle or any alteration of heading into the wind. So as soon as you reach this point, subtract the whole 6 degree and then fly straight on this radius 045 outbound, because it's still air conditions. You don't need to point your aircraft into the wind. So very important. So the correct answer is option A. It's a left hand turn for sure, and it will be 045 heading. Still air conditions. Next, question 18. DME operates in the frequency band UHF. It transmits in the frequency band. What frequency band is it? 962 megahertz to 1213 megahertz. And the designator is P Papa 0 November. Now, what is the meaning of this Papa 0 November? That is very important. The meaning is, on page On modulation chapter, page number 44, you will find all the meanings. Emission characteristics. Now here Papa stands for sequence of unmodulated pulses. So we all know that DME pulse pairs are not modulated. They are not amplitude modulated. They are not frequency modulated like ILS. Zero stands for no modulating signal, and November stands for no information transmitted. There is no audio information transmitted or anything like that specially. So P0N stands for that. Remember this amplitude characteristics for all equipments, and you must remember all this, especially for your RTR YY exam. For ADF, for VHF radio telephony, for high frequency radio telephony, VOR, ILS, marker beacons, DME, and microwave landing systems. So remember the emission characteristics for all of them. Next question. Question number 19. Referring to DME, during the initial stage of the search pattern before achieving a lock-on, the airborne transmitter will transmit at what rate? So correct answer is Bravo. Always remember, whenever you switch on the DME equipment in your aircraft, or you change the DME channel frequency, first it will enter search mode. In this search mode, it will start searching for suitable DME stations nearby that can give accurate range information. In this search mode, it will transmit 150 pulse pairs per second. This search mode will last for 100 seconds, and in this 100 seconds it will have transmitted 15,000 pulse pairs. 150 into 100 is 15,000 pulse pairs. Now if this search mode is a failure, okay, it's not a success, it will reduce in that scenario. If the lock-on is not achieved, in this search mode, the scan rate or the search rate gets reduced to 60 pulse pairs per second. 16 pulse pairs per second. Once lock-on is achieved, the DMA will start or will enter tracking mode. In this tracking mode, it will transmit 25 to 30 pulse pair, 25 to 30 pulse pair per second, pulse pair per second. So correct answer here is option Bravo. In the search mode, airborne transmitter transmit 150 pulses per second. Next, 20. DME and VOR are frequency paired because the same receiver can be used for both aids. No, DME receiver and VOR receivers are different. VOR is OBS selector. For DME we do not have OBS. The VOR transmitter is easily converted to required DME frequency. No. Cockpit workload is reduced. Yes. Both ground transmitter aerials can be placed on the same site if required. No. So most suitable option is option Charlie. When frequencies are paired, selection of one frequency, let's say VOR frequency, will automatically activate DME frequency also. So that cuts down your workload. So option Charlie. Last, DME receiver is able to distinguish between replies to its own interrogation and those intended for other aircraft. Again, a similar question. Many times they have asked this because the reply pulses of one aircraft will be unique or will be different from reply pulses of another aircraft. So DME is a secondary radar and each aircraft transmits and receives on a different frequency. Statement is right, but this is not the answer. DME transponders reply to interrogations by means of twin pulses, and airborne equipment rejects all single pulses. Statement is right, but this is not the answer or justification for this particular question. Each aircraft transmits pulses at a random rate, jittering, and will only accept replies that match this randomization. Yes. When DME is in the search mode, it will accept only pulses separated by plus minus 63 megahertz from the interrogation frequency. Statement is right, but not the justification or reasonable answer to this particular question. So option Charlie is the correct answer. And this successfully ends our lecture. I hope you have understood all the 11 questions I answered, the explanations I gave. Okay. So if you have any doubt, questions, feedback, let me know in the comment box of this video lecture. Keep practicing all the questions, keep working hard, read the theory thoroughly and carefully, and practice as many questions as possible. Increase your confidence. Please subscribe to this channel if you haven't yet. Share this video with your friends and hit the like button if you have liked this video lecture. All the best. I'll see you in my next video lecture.